Okay, let's take a look at counting outcomes with a little bit more application. So this is going to be a little more in-depth than what we were just working on with the basic ideas. Again, what does it mean to count an outcome? It means to be able to determine all the possible outcomes that can happen. Now that's important because if you're not able to determine all the possible outcomes that you can have in a given event or situation, then it's impossible for you to figure out what's your probability. Remember, the probability for an event is completely dependent upon, let me get this set up for you guys. There we go. The probability for an event, which we'll call P of an event, means that if will something happen or not, is totally dependent upon two things. The event happening, okay, all divided by all possible outcomes. And as we discussed last time, say for example that you are rolling a die. There's 6 sides to a dice, so therefore if you were to roll at one time you get a 2, then you would know that the chance, the probability that you would roll a 2 is 1 out of 6, because there's 6 possible outcomes when you roll a die. So let's take a look. This is a little bit more in depth, a little bit more coverage of an application for counting an outcome. It says, during a visit to a college, Tanya made a list of academic buildings. Of the 7 buildings on the list, 5 were built in the 1800s. If Tanya randomly chose 4 buildings to visit, what is the probability that all the buildings were built in the 1800s? So let's draw a picture of this. Tanya goes to college and she notices that there's 7 buildings. And let's see, we need one more. Okay, so very quickly, here's an illustration of all the buildings. Okay, we're going to call this building number 1, building number 2, building number 3, building number 4, building number 5, and building number 6, and building number 7. Now, let's go back up to our problem. It says that 5 were built in the 1800s. So let's just list 5 of the buildings. We'll make number 2 the 1800s, number 3 the 1800s, number 4 the 1800s, number 5 the 1800s, and number 7 the 1800s. Now, well, I don't know why she was concerned about them being built in the 1800s, but maybe there was just a little bit of history there that she wanted to discuss. So we want to be able to determine the probability that all of the buildings that were built that she picked were built in the 1800s. Okay, so she's going to pick 4 buildings to visit out of the 7 total. Okay, so the very first thing that we need to do is to figure out the total possible outcomes that you can possibly have here. Okay, so let's see if we can figure out the total possible outcomes. So let's see if we can figure out what all the possible outcomes are. Okay, all the possible outcomes would be what? There were 7 buildings, okay, and she's going to pick 4 out of those 7. Now, we don't care about the order of those buildings, do we? We just know that she's going to pick 4 out of the 7. So therefore, it's going to simply be 7 buildings picked 4 at a time. She's going to pick 4 of those buildings. We can calculate what that will be in just a minute. Now what we need to do is to figure out the event, meaning what event are we dealing with? Well, it says that the probability that all of the buildings were built when? In the 1800s. Okay? Well, 5 of the buildings were built in the 1800s. She's going to pick 4. So therefore, it's going to be the 5 buildings that were built in the 1800s. We do not care about order at all. So how she's going to do this is she's going to pick 5 or the possibility would be 5 of the buildings picked 4 at a time. So there's 7 total that she was going to pick, 4 at a time. Okay? So if we do our calculation for that, okay, you can go through and do it. Remember, what is 5C4 would be the permutation of 5 items taken 4 at a time, all divided by 4 factorial. So it's going to be 5 times 4 times 3 times 2. We only want, even though that 1 is there, we only want the first 4, right? All divided by what? 4 times 3 times 2 times 1. Okay? In which case, the 4 and the 3 and the 2 are going to disappear, and we're simply going to be left with 5. So therefore, the event has a chance of 5 here. All right? So that's the value of that possible event happening. Now, what about the total possible outcomes? Well, that's going to be 7 buildings picked 4 at a time. Okay? So that's going to end up being what? The permutation of 7 picked 4 at a time, all divided by 4 factorial. Again, we should already be able to do our calculations for 7 items picked 4 at a time. So again, it's going to be 7 times 6 times 5 times 4. Now we're going to stop there because we only wanted the first 4. And now we're going to divide by 4 times 3 times 2 times 1. All right, the 4 is gone, and 3 times 2 is 6. That's gone. And 7 times 5 is 35. So therefore, to find the probability of Tanya picking 4 buildings at random and all of those buildings being built in the 1800s, if you do the math calculation, you're going to end up with 0.1429 if I round, okay, to 4 decimal places. So roughly there's about a 14% chance of her picking 4 buildings at random and all 4 of those buildings being built in the 1800s. Okay? Let's take a look at one more example. And if you want to, you can pause the video and see if you can work this problem all by yourself, and then go back and take a look and see what the final outcome would be, okay, for this problem. All right. It says John bought 11 donuts to school, 3 of which were chocolate. If John randomly gives away 8 donuts to friends, what is the probability that exactly 2 of the chosen donuts are chocolate? All right, now this problem is a little bit more complicated. But at the end, we're still going to end up with finding a probability. So let's remember, it's the probability of the event is equal to basically the event all divided by the total outcomes. Okay? Now what we need to figure out first is our denominator. So what's our total outcomes here? Well, there are 11 donuts and he's going to choose 3. So therefore, it's going to be 11, and we don't care about order again, so that's why we're using a combination. 11 donuts picked 3 at a time, and again, we do not care if he chose like a raspberry or a cream filled or anything. We don't care about that. That's his total outcome. Okay? Now what we have to do is we got to do a little bit more in the way of thinking now. Okay? What I mean by a little bit more in the way of thinking is this. He's going to choose 8 donuts he's going to give to his friends, and the probability that exactly 2 of those donuts are chocolate. So what we have to do is a little bit of mathematics here. Okay? First off, we know that he's going to, there are 3 donuts that are chocolate, and he wants to know the probability that if he picks 8 donuts, what's the chance, the probability that 2 of those are going to be chocolate. So if I look only at the chocolate donuts, okay, let me write this over here. Chocolate donuts. Only at the chocolate donuts, that's going to be 3 taken 2 at a time. Because there's 3 chocolate donuts total, we're going to pick 2 at a time. So therefore, just looking at the chocolate donuts, I'm going to put that in my possible event. Now, that's not all, because that was just the chocolate donuts. What about the other donuts? And you'd say, what do you mean, what are the other donuts? Well, there were 11 donuts total. Now, this is very important. And we're just going to pick 3 of them out, okay, because they're chocolate. So we're going to take the chocolate out of the way. So what I'm going to do is write the word other up top here times the chocolate. Hope that makes sense to you. So how many donuts would be left over? Okay, well, 11 minus 3 is 8, all right? And he picked 2 that were randomly hoping that 2 of them would be chocolate, but he's going to pick a total of 8. So 8 minus 2 is 6. Now, I know that's a little bit confusing, but think with me for just a minute. If I took 8 plus 3, that would be 11 total donuts, okay? And how am I getting the 6 here is because he wants exactly 2 of those donuts to be chocolate out of the 8 he's taken, okay? So I know that there were 3 total. I know this is getting a little bit confusing, but all I'm really doing is just focusing on what would be left over. Of the 8 total donuts that he has, if he takes 2 of them away because he knows they're chocolate, there's going to be 6 left over. So now we have to simply do the math. So the other donuts would be 8 taken 6 at a time. Okay? So here we go with the math. It's simply going to be what? A permutation of 3 items taken 2 at a time, all divided by 2 factorial. So it's going to be 3 times 2, all divided by 2 times 1, which is just 3. Okay? So this is going to become times 3 up here. We're going to do the math real quick. 8 taken 6 at a time is going to be the permutation of 8 items taken 6 at a time, all divided by 6 factorial. So we want the first 6 out of 8. So it's going to be 8, 7, 6, 5, 4, 3. That's 1, 2, 3, 4, 5, 6. Okay. All divided by 6 times 5 times 4 times 3 times 2 times 1. Okay. Well, the 6, 5, 4, 3 can be reduced. And of course, the 8 and the 2 divide, and that will be 8 divided by 2 is 4. So that's going to end up giving me 28. Okay. So of 8 donuts taken 6 at a time, there's 28 possible combinations. Of 3 chocolate donuts taken 2 at a time, there's 3 possible combinations. Now we need to get the total outcome. So the total is going to be 11 taken 3 at a time. So that's going to be the permutation of 11 taken 3 at a time divided by 3 factorial. Okay. Which is going to give me, hope you can see all of this, 11 times 10 times 9, all divided by 3 times 2 times 1. Well, 9 divided by 3 is 3. All right, so I'm basically going to end up with 30 times 11. Okay, all divided by 2, which is 330 divided by 2, which is 165. Now, if my math is correct and everything works out here, I'm going to end up with 84 divided by 165, or approximately 0.5091. So my probability is 0.5091 that of the 8 donuts that John was going to select, 2 of them would be chocolate. I hope this helps, and I realize that this is a little bit more advanced application of counting outcomes. But remember, we're using a combination because we do not care about order. However, in order to calculate a combination, we needed to know what a permutation was. And using, working with figuring out all the possible outcomes that you could have, that would be your denominator. And then the possible outcomes that you would have for the event would be your numerator. I hope this helps you when you're completing your assignments.